Welcome to Introduction to Force, AP Physics 1 Unit 2. Force is the interaction between objects. It has a unit of Newton. 1 Newton also equals to 1 kilogram times meter per second squared. When we consider a target of a force, it's usually acting on a system. A system is a group of objects, and a system or an object cannot exert force on itself. For example, if you're standing on an elevator and you consider you and an elevator as a system, then the force you act on an elevator and the elevator act on you is actually called the internal force. So there's no net force on the system. Force is a vector, so it has both magnitude and direction. Net force is a combined, unified single force acting on a system or an object. We can separate it into two components. It's similar to when we talk about combined velocity in kinematic, where we separate velocity into horizontal and vertical components. So in this case, we also have F net x and F net y. And it's obvious that F1 is just the vertical component and F2 is a horizontal component. But F3 is a little bit tricky because it has both horizontal and vertical components. So what we can do is we can draw out the F3y and F3x to represent each component. Conventionally in physics, it's similar to kinematic. The right and up is positive and down and left is negative. So F net x in this case is really just F2 minus F3x. And F net y is just F1 minus F3y. The vector sum of force is just a net force. It's a single unified force, so we use the Pythagorean theorem to combine the horizontal component and vertical component. When we say it's balanced, it really just means net force is zero, or the force totally counteracts itself. For example, there's a force upward and there's also a force downward. And if they have the same magnitude, then we said it's balanced vertically. So we're ending this video with a physics fact, or it's also a common misconception. When an object is not moving, it's not instantaneously. It's when it's not moving for a long time. We can say the net force is zero. But if we say it oppositely, when the net force is zero, we cannot say object is not moving. We'll figure out why when we learn Newton's first law. But that's all for today's video. See you next time.